All right, well, welcome back, everyone. Let's go ahead and get started with working with files in C++. So, goals for today. So, by the end of today's video, we want to help everybody understand how to manipulate data files using C++. We'll also see that in order to manipulate our data files, we're going to need to use some of the tools we've already learned, including loops, if statements, and Boolean statements. If you happen to be rusty on loops, if statements, and Booleans, I'd encourage you to review some of our previous videos. We will also demonstrate several examples of simple programs that use data files. So real quick, let's start with a quick review question from our previous video. In our previous video, we covered how to write loops. And so in this practice question, we want to write a program which uses a loop to ask the user, "Are we there yet?" And the loop will take a string answer from the user. The program should keep repeating the question, "Are we there yet?" until the user answers either capital Y or lowercase y, meaning we have arrived. So let's take a moment and think about how we would approach this. If you'd like, try pausing this video and attempting this program yourself. So what kind of loop should we use for this program? Well, do we know how many times this loop should run? Not really. We don't know exactly how many times this loop should run. So, in this case, a while loop is a good option. What we can do is we can use the while loop to keep asking, so we keep asking, "Are we there yet?" Keep asking, "Are we there yet?" until the user answers big Y or little y. So basically here, we just have a few main steps. First, we need to declare a string variable to hold the user's answer. Once we've declared that string, then we can ask the question, "Are we there yet?" and get the user's reply. And we keep asking as long as the reply is not the desired answer. So notice here I mentioned we could use a while loop, but another good option could also be using a do while loop. So I would recommend here either using a while loop or a do while loop. Let's go ahead and try coding this up in CLion. And so remember what we need to do. First, we need to declare a string variable to hold the user's input. Just in case we need fancy string functions later, I'm going to go ahead and use the string header as well. So in this case, let's go ahead and call it string user reply. So that will be the user's answer to the question. And what we can do is we can initialize user reply to a temporary value. Suppose, okay, so notice if my user reply becomes the same as big Y, or if my user reply becomes the same as little y, then this while loop will suddenly become false. And once that while loop becomes false, then our program will stop. So here we can give our user a hint. Are we there yet? Enter yes or no. And here we can say cin, and we can take in that user reply. And then finally, when our loop does indeed end, we can, hooray, we made it. So there we have it. Let's go ahead and try running this program, and let's test out all the cases. So we'll go ahead and run. Are we there yet? And see what happens. So, are we there yet? Enter yes or no. No, I'm not there yet. Notice, as long as I say no, or if I even say another letter that's not Y, I'm still getting no. But as soon as I enter yes, hooray, we made it. Or, notice right in the beginning, I could say yes, we made it, and just give a capital Y. So notice here I do need to use and for this Boolean. If I said or, the statement would still be true even if I had answered Y for yes, and then our loop would keep running. All right, so just a little more review from last time. Remember, last time we also covered variable scope. And here, when we say scope, we are referring to the part of a program where a variable exists. And remember, we learned that if we declare a variable inside some curly braces, the scope of that variable is basically the point at which it's declared to the end of the curly braces. So a variable does not exist outside the braces where it was declared. The reason this is important is because if we declare variables inside loops or if statements or other functions, we want to be careful not to make those variables unavailable if we need them later. We also discussed loops. So make sure that you can recognize which type of loop to use for a given situation. Remember that while loops will repeat as long as the Boolean statement is true. Do while loops are guaranteed to run at least once, and they will continue to run if the Boolean statement remains true. Finally, for loops are useful when you need your code to run a specified number of times. One other thing to watch out for is you want to make sure your code inside your loop will eventually cause your loop to stop. We need to make sure that Boolean statement eventually becomes false. Otherwise, the loop will run indefinitely and create what's called an infinite loop. Okay, so if you have any questions on this, feel free to reach out. Now we'll go ahead and continue with working with files. Let's start with a few definitions. You may remember hearing the words input and output streams. Remember include IO stream? So here, when we refer to a stream, what we're referring to is a flow of characters or other kind of data. So this is not a flow of water like in a river, but a flow of data. And so an input stream refers to data flowing in to the program. For example, we could have data coming from a file, from the keyboard, from the cloud, and we send that data through an input stream into our program. Similarly, an output stream refers to data flowing out of our program. So in this case, we take data from our program and we send it off to a data file, another document. Maybe we push it to GitHub or somewhere else. Input stream refers to data flowing in. Output streams refer to data flowing out. So I mentioned our header file include IOStream. Remember that? It turns out we have already been using input and output streams. When we use the include IOStream header file, we gain access to cin and cout. Cin is an input stream that sends data from the keyboard into our program. And cout is an output stream that sends data from the program to the monitor. So it turns out that working with data files is actually very similar to using cin and cout. But instead of sending data to the keyboard and monitor, today we'll learn about sending data from an input file into our program, or sending data from our program into an output file. So using files is similar to using cin and cout. So why are we bothering with files? There's a lot of reasons why programmers and engineers need to know how to work with files. For this class, and for future programming classes that you may take, you're going to need to be able to use data files when writing programming assignments. You may have some assignments where you need to process data from someone else's input file, or maybe your program needs to send data to some output file. Or maybe you're an engineer working in industry. You have some data from a machine that's in a data file in one format, and you want to be able to process it and perform calculations on that data. So you'll definitely need files for future programming assignments. And let's be real, most of the time, engineers and computer scientists work with large amounts of data. It's just not feasible to sit there at the keyboard and type in data into your program. Most of the time, we will be using data files and other sources to provide us with data. Once again, we don't want to manually enter everything, so being able to write to and from files is important. And finally, it's very important that we're able to save our data between runs of our program. Remember, normally a program's data will disappear when the program is shut off, so storing your data to a separate file in the secondary memory will allow us to save data between runs of the program. So in today's class, we're going to look through the different steps of using a file in a C++ program. These are the 6 main steps that we will follow. I'll briefly explain the steps here, and we'll demonstrate them in a C++ program. All right, so once we're done with the demo and this high-level explanation, we will take a closer look at each of these steps to understand what's really going on in each step. So, initial step we want to do, we want to make sure we put files in the same directory as the CPP file containing our main function. That way, we can easily find the data file when we're compiling our program. Next, we need to remember to use the include fstream header. That allows us to create file stream objects, which are needed in order to manipulate data files. Next, we declare input and/or output file stream objects. So if you read from a file, you need an input file stream object. And of course, if you're writing to a file, you're going to need an output file stream object. And notice if you need to read and write to multiple files, then you would need to declare multiple file stream objects. You basically need one file stream object for each input and each output that you're using. In other words, if you're writing a program that is sending data to or from many files, you're going to need many file stream objects. Once we have our file stream objects, we use the open function to link a specific file to an input or output file stream object. A good practice at this point is to check and make sure that that file opened properly and that the file was found. So good practice is to check for errors using the fail function. Once we've checked for errors and everything is fine, you'll see that we can use the input and output file stream objects in the same way as we use cin and cout. So just like how cin reads from a file, input file stream object, input file stream object will read data from a file, And then, of course, the output file stream object can be used to write data to a file. And finally, the last step, you want to make sure you close your files using the close function when you're finished reading and writing. We'll explain why that's important a little bit later. So before we go into deep details on each of these steps, let's first just show you the entire process of reading and using a data file in C++. So I'll go ahead and code up this demo so you can see what it looks like if I want to read and write to a file using a C++ program. All right, so let's go ahead and walk through what this code looks like for manipulating a data file in C++. Since we're going to be working with strings and we're going to be working with data files, it's a good idea to include IOStream, string, and FStream headers. Also, you'll want to include using namespace standard if you want to use cin and cout just as they are. We declare a main function, and look what we do first. Here, we declare variables to hold the name of the input and output files. Notice I gave them descriptive names. Input file name will hold my input file's name, and output file name will hold my output file name. You'll notice I also declared these other variables, string input data and string output data. These are to give us a place to store the next item to be read or written from the file. So input data would store an item read from the input file. And output data can be used to store an item we want to write to the output file. We'll see later that sometimes it's helpful to have these variables available for us. Notice these next items here. ifstream in file, ofstream out file. Look what I'm doing here. By writing ifstream in file, I am declaring an input file stream object named infile. So ifstream here is the type of object I'm creating. So in this case, just like how I would declare, a string variable named input data, here I'm declaring an ifstream object named infile. So notice we get to choose the names of our input and output file stream objects. So here I just chose to name my input file stream object infile and my output file stream object outfile. So we'll talk a little bit more later in the course about what objects are. For now, just remember that we need to use ifstream infile if we want to do inputs and read input files. We must have ofstream outfile to make an output file stream object. Output file stream objects are required if we want to send data to a file. So note that input file stream objects are required for reading data from an input file. And then output file stream objects are required for writing data to an output file. So here we have declared those objects and given them the names infile and outfile. Next, it's time to actually ask the user for the input and output file names. So we ask our user, give us the name of the input file that we want to read from. Normally, the user would need to either have the file in the same folder as the program. Otherwise, you'd need to provide the full path where that file is located on your computer. So the user gives us the names for the input and output files that we want to use. Next, we use what's called the open function in order to open the data file and create a link between the data file and the input file stream object. So here, notice I take the input file name. This is a file I want to read. I plug it into this open function. And I use the syntax infile.open input file name. Don't worry too much about this dot operator and functions just yet. We'll learn more about those later in the class. For now, just remember this syntax. And remember, we're taking our input file stream object. We're using the open function so that we can open input file names file. Same approach with outfile. So if we want to open our output file so that we can start writing data, we need to open our output file. So here we're using outfile.open output file name. As you saw, our next step was to check for errors when opening the file. So here we can use this function called fail. So here we see if infile.fail, if our input file failed to open, then we can give ourselves an error. And here we can do an exit. So this will cause my program to end and display the integer 2. If you've ever done any work with error codes before, this is basically a way of communicating why the program ended. So here, this is one way of saying maybe error code 2 means that we couldn't find our input file. Here comes the fun part. Assuming that we have opened our file and done everything correctly to this point, notice we can use infile and our extraction operator to read from the data file until we see whitespace. So we can use our input file stream object to grab the first item from the file until we see whitespace. This is just like cin. Cin will read the first item from the keyboard until we see a whitespace. If we want to read an entire line from the file, we can alternatively choose to use this getline function. Notice that getline requires include string. So if you want to use getline, make sure you include string. And what you do is you say getline, you give it the name of your input file stream object and the variable where you want to store your data. And so here you can see we have a line of output saying the rest of our first line would be input data. Now we want to ask our user, okay, what message would we like to send to the output file? We've taken some data from our user. If our user gives us a whole line, we could also alternatively choose to read an entire line. And then we just simply write output, outfile, output data. And this works just like cout. It will send whatever is in output data to the data file. Finally, last step, we need to remember to close our files. So closing files is important to make sure there's no data loss, and it helps prevent errors. So here, we just simply take the name of our input and output file stream objects. We write infile.close with empty parentheses, outfile.close, empty parentheses. That closes our data files, and we are finished with the program. So it seems like there's a lot here, but I promise once you get some practice writing these programs and using these tools, things will become a lot easier. Let's try demonstrating this program. Suppose I have an input file called input data. So inside inputdata.txt, I have a message. Hello world, my name is input data. I'm a data file. Nice to meet you. I also have an output file called outputdata.txt. Right now it has the word hi in it. I'm just going to delete all the data in that file so that we can write some new data in there. So let's try running our input and output demo that we just reviewed. And let's try reading and writing to input data and output data.txt. So I'm going to go ahead and run this program. So notice the first thing I need to do, I need to give it the name of my input file. So here, I want to read from inputdata.txt. Since inputdata.txt is already stored in the same location as the CPP file, I don't need to worry about putting the full path. So the output file I want to write to is called outputdata.txt, so I give it that file name. And notice now some stuff has happened. So notice my program read the input file. Here is the first word from the input file stream object. So the first thing that was in my input data file was the word hello. So notice, because I read until I see white space, the input file stream object will read hello and then stop. If I want to read the rest of the line and read all of this entire line, then I need to use getline, remember? And you'll see if I use the getline function, then I see the rest of my message. Hello world, my name is input data. I'm a data file. Nice to meet you. You might have noticed that the output on this sea lion view is a little bit staggered, like the spacing and the new lines are funny. That's just because of this output console here. But you can still see that the program successfully read the first line from my file using getline. Notice now I'm at this point in my program. What message would I like to send to the output file? Well, let's just say, greetings. My name is Professor Erickson. So I wanted to send that whole message, but notice I only read the very first item using cin. So in this output file, when I open it, I'm only going to see the word greetings. If I want to see the entire line, I would need to instead use getline. See, if I look in my output data file, the program has written the word greetings to that file. So now that we have demonstrated this program to read and write to a data file, let's go ahead and review each of the steps we followed in a little bit more detail. Now that you've seen the whole process, we can understand the importance of each step. So first, a very important initial step is you want to put files in the same directory as your CPP file that contains your main function. So when we say directory here, what I'm referring to is a location on your computer. And notice if you are using CLion, you may need to include this extra line, and this will set the files and the outputs to appear in the current directory. So this tells CLion, if you're looking for data files, please look in the directory where the main function is stored. Generally, for assignments, this will be done for you, but if you're doing any practice on your own, you would want to include this line so that CLion knows where to find the data files. Okay, the next thing we need to remember is we need to use include filestream when working with data files. The include filestream header file is required for file access. That is because filestream includes the code needed for the input and output file stream objects. It's also a good idea to include the string header if you are using strings or string functions like getline. And so you'll see in our sample program, we included both of those headers. So the next thing we did in our demo was we declared input and output file stream objects. So it's kind of similar to declaring a variable, except in this case, we are declaring an input or output file stream object. So if we want to read input data from a file, we use ifstream to create an input file stream object. And notice I get to choose these names. So I chose to call my input file stream object infile. Similarly, if I want to write to an output file, I create an output file stream object. And here I just went ahead and named mine outfile. So you can call them whatever you want. It's a good idea that you give them a descriptive name, just in case you need to write a program that contains multiple input and output files at once. Remember, you need a separate file stream object for each input and each output. So you can't have the same data from multiple files passing through the same file stream. That won't work. Every input and every output gets its own private file stream. Also, as I mentioned, the terms object and file stream might seem new and unusual. And please keep in mind that we're going to be covering functions and objects later on in the class. So don't worry too much about knowing what exactly an object is and what a function is at this point. We will cover those in more detail later. For now, just focus on memorizing the syntax and using it to manipulate data files. Okay, so as you can see in our example, we successfully declared our input and output file stream objects. Next thing to do is we use the open function. And so the open function will link the data file to the input or output file stream. So in this case, if I have a data source like input data.txt, if I use input file.open and then the file name, it will put that data in the file stream. And then we can read that data either piece by piece or using getline in order to send it to our program. So you saw that we use our filestream object and the open function to open a file and access the contents. Notice the important thing. We have to use that open function. We can't read or write to a file unless we open it first. So that's why the open function is so important. Once again, there's the open function in our example. And you can see in this case, we took the name of our input and output file streams, dot open, and we used the string variables for input file name and output file name to hold the names of the files. It's always a good practice to use variables to hold the file name. Usually we do not want to directly code file names into our code. If we use variables, then it's much easier to change that file name to something else depending on what's going on. So here's a common bug that sometimes comes up. So one thing that can happen is when people are writing file paths contain slashes, which could be confused with \t, \n, and the other escape sequences. So make sure if you are writing a full file path, use double slash. That way you don't accidentally get a \n confused with a new line. Windows will also accept the single slash in the reverse direction. All right, one more quick comment. So once again, we saw my input file.open or input file.open in that function. This dot is called the dot operator. And specifically, that dot operator tells the compiler to run the open function associated with the myInputFile object. For now, just worry about remembering the syntax, and we will revisit the dot operator and functions later on. A couple other notes about the open function. First, the input file must exist in order for our open function to work. And inside that open function, you need to either put the file name in double quotes or a string variable containing that file's name. If you're using output file.open, notice an output file with the specified name will be created if necessary. Be careful here. If you try to output data to an existing file, that existing file's contents will be erased and overwritten. So please be careful if you use output file.open. Make sure that whatever file you are writing your data to is not containing some important data that you don't want to lose. Once you use output file.open with an output file, any data in that file will be erased and overwritten. Also, as I mentioned previously, you must use separate file streams for each input or output in your program. Notice each input or output must receive its own file stream object. The program will look in the local directory or the same folder as the folder holding your CPP file. So if your data files are not stored in that local directory, you need to give the full path on your computer so that that file can be found. And so you want to make sure you keep those files in the same folder as your program's CPP files. Otherwise, you might run into errors. Note that typically for assignments I give, you don't need to worry about this because the files are usually placed in the correct location already. Let's do a quick practice question. Suppose I use the below statement to write to an output file. So here I'm using the open function and I want to open report.txt and be able to write data. So my question to you is, what happens if that output file already exists and that output file already contains data? Do you remember what will happen? So you might remember, in this case, choice C is the correct answer. If we open a data file that already exists using the output file stream object, the file will be overwritten and any original data will be lost. So once again, opening an existing output file will delete all the data in that file. To be safe, you can also choose to create brand new output file names so that you avoid possibly deleting data. And there are some more advanced features like appending, which we won't cover in this class, but if you're curious, you can learn more about how to modify existing data in your files. Okay, the next thing we checked for, the next good practice in our procedure, was checking for file opening errors. And so one way to do that is using the code like this. So this .fail function, or fail, the fail function will return true if the input file stream object was not, did not successfully find the file. And so here, notice inside our if statement, we can give an error message. And if needed, it's often a good idea to completely exit the program using the exit function. So this will completely end your program and return the error code inside. So here we are returning error code 2. Here's another way to check whether the filestream object has successfully been created. So you can also use the not operator if my input file is my input filestream object. Notice not my input file. This will be true if the input file stream object wasn't created, or if it's empty. And of course, that would happen if we had failed to open the file. So if we were unable to successfully create that file stream, we return true. In this case, because not my input file would return true, then we get the output message. So the next thing we learned in our demo was that file stream objects behave like cin and cout. So as we saw, we can use the output file stream object, just like cout, to send data to a file. We can also use the input file stream object in order to copy data from a file to our variables. This is an extremely important tool. These file stream objects, they allow us to read data from files one item at a time. And so this way, we can easily extract from a data file containing numbers and text. We can read each item individually from that file. And the same rules apply. So with cin, we read until we see white space. Cout, we can use escape sequences in order to format our outputs. So my input file or input and output file stream objects work the same way. So one other important thing to note here, for this class, you must know how to use file stream objects in the same way as cin and cout. Some C++ courses only cover how to use getline to read data from files. The problem with getline is this reads lines of text as strings. And if you have a data file with a bunch of numbers, it's a pain to have to convert. So it can be a pain to convert strings into other values like numbers or chars. So for this course, most of the time, we will use the input and output file stream objects instead of getline. This way, we can read each item from the file one at a time. So please be aware of this. This is not to say that getline is bad. There are certainly situations if you want to read an entire line of text from a file, getline can be an excellent tool. But especially in engineering applications and applications where we have files with numbers and data, we need to be able to read those items one at a time. And so that's why our focus will be on using the file stream objects like cin and cout. So as we noted, the input file stream object will read until it sees white space, in the same way that cin reads. Another very useful bit of information. Suppose I have a data file that contains hello world, my name is Professor Erickson. If I wanted to read this data file, if I wanted to read the data file, I could use the input file stream object and I could read each item one at a time. So first I would read hello, then I would read world, then I would read my. So we have to read items from the file in order. So if we want to skip an item, like say we have a part number and then some data, we have like part 1 and then data, part 2, part 3. Notice here I would have to write in file if I had like a string variable named part. I could use in file part to read part, and then I could use in file data to read the data. So I can't skip items. I have to just simply read the item I don't want and store it in some other variable. So here I would first have to read part, store it in a variable. Then the next item, data, I could access. So if I want to skip all the data in that part column, then I would always need to have an in-file part to read part, get it out of the way, and then I could read then the second item to data. So that's what we're mentioning here. If you want to skip items when reading a file, you want to use the input file stream object to read the thing you want to skip to a temporary variable. Get that unwanted data out of the way, then store the data you do want into another variable of your choosing. Also, as we demonstrated, when outputting to a file, you can use escape sequences. So for example, you can do things like end line. We can do \n, \t, and other different formats. All right, one last point. So we did briefly demonstrate the getline function. And again, as I mentioned earlier, getline is useful for reading entire lines of text, but it isn't so good for reading individual values. So most of the time in our class, we're not going to use getline. Most of the time, we have to use the file stream objects themselves, not getline, for file manipulation. But if you do need to use getline to read an entire line, then this is how you would do it. So here you put where you're reading the data from. So this is the stream, input stream the data is coming from. So this could be a cin, or it could be like an input file stream. And then name is the name of the string where we want to store the data. And if you happen to have a new line in front of getline, then remember you might need to use cn.ignore if you have a new line right before using getline. Sometimes we need that cn.ignore to prevent getline from reading a new line and then immediately exiting. So here's a couple more examples that we saw in our earlier demo. So we saw that if we use infile, our input file stream object, and have it read into input data, this will store the first item from our file. So we'll store the first item from the file in the variable input data. And of course, if we want to read an entire line from the file until we see a new line, then we can use getline. And again, this is generally only useful if you are reading a lot of text, which is not very common in this class. And then as we saw, of course, we can write to our output file using outfile output data. We can also use this getline cn output data to read the entire line that's provided to output data. But here, since we had a new line from our cin statements, we'd also want to have cn.ignore before the getline. Okay, so the last thing we saw in our demo was that we need to use the close member function in order to close a file. And so this is pretty easy. We just take the file stream object name, and then we say dot close. Put empty parentheses and a semicolon. This closes the data file, and it helps us avoid errors and data loss. You don't want to wait for your operating system to close files when your program ends. There actually might be some limit on the number of files you can have open at a given time. And there might also be some data sitting in an intermediate buffer. And so you don't want to lose that data if it has not yet been sent to your file. So it turns out really the main reason why we need to close a file is because when we write data to our files, we actually write to an intermediate buffer. And that buffer is transferred later to the data file. Once the buffer gets sufficiently full, it gets flushed to the file, meaning the contents are emptied into the data file. Closing the data file forces the buffer's contents to be written to the data file, and that ensures that nothing is left behind. So once again, if you forget to close your data file, you might accidentally leave data behind in that buffer, and your final results might be missing some data. So just to summarize, that concludes our whole sample program for reading and writing to files. And I highly recommend that you go back in and play with this example on your own. Let's cover a few more important points. First is using loops. So you saw that when we were manipulating our file, we were simply writing in file and then we were reading to some input data variable. But we don't want to sit there and write in file input data a million times. It turns out that what we can do is we can put that in file input data inside a while loop. And this is actually a very nice way to use a loop to read a data file. So our stream extraction operator, that's the thing that cin and infile use, that stream extraction operator will return true when a value was successfully read. Operator will return false when we have not read a value. So therefore, if I were to rewrite my program as while infile reads input data, I could repeat my loop until all the items have been read from my file. You just want to be careful, of course, because notice this input data variable would be overwritten with the next item. But this is a very powerful tool, and using the stream extraction operator in this way, this is extremely important. We're going to use this a lot. So let's take a look at another example. Here we have some code that will be reading a file using a loop. And you'll notice that the setup is still very similar. We still have to declare our variables, make our input file stream object. We still get the file name and check for errors and use the open function. So the initial procedure is used to set up the file and make sure we're ready to open. Here's where our loop comes in. Notice we have a while loop, and as long as we are able to read the next item from the file, then we output that item back to the screen. Let's quickly run this in CLion so you can see how it works. So here's our sample program. And once again, you can see we are trying to read data from our input file into input data, and then we are immediately outputting the thing we read back to the screen. Let's go ahead and run that with our old input file. So we can say read from input data.txt. And look what happened. We read from the file. Here are the contents. Hello world, my name is input data. I am a data file. Nice to meet you. And it even read my second line. So it literally went into my input file, input data.txt. First we read hello, then we read world, then we read my name is. So we read this one word at a time. We read each item separated by white space and outputted it back to the screen. Suppose we only wanted to read every other word. What if we wanted to skip a word? If we wanted to skip a word, what we could do is we could either just overwrite input data, or we could declare some dummy variable. I'll just say what we can do is we can take the data we don't want and we can read every other item to dummy variable. We skip every other item. And so if we do this, you'll see what happens now. Notice what we did. We first read in file input data. This gave us hello. So we first read hello, then world got read to dummy variable. We did not output it, so it just disappeared. Then my got read and outputted. Name was read to the dummy variable. Then is was outputted. Input data.txt went to the dummy variable. Notice I'm appeared. So if we want to skip over data that we want, we still have to read it from the input file stream, but we could just store it in another variable that we don't use, and that way we can skip what we don't like and save the data that we want. Okay, so now let's take a look at an example that is a little bit more focused on something a data scientist or engineer might do. So I would like to code up from scratch a program that calculates the maximum and minimum value of 200 numbers read from a data file. I highly recommend you try going back through this demo on your own or code along with me. And so here's our demo. We have a data file containing 200 random numbers. We want to write a program which will open that data file, read the 200 random numbers, and find the maximum and minimum of those numbers. The program should output the maximum and minimum values back to the screen. And notice for this case, if you're using our sample code, the CMake directory will already have this line of code in it, but otherwise, remember you can set the current directory to be the place where CLion looks for your data files. So let's try coding up this demo and follow along if you'd like. So I'm starting out with an empty main function. Let's just briefly review what we need to do. Well, we need to declare variables to hold file name, maximum value, minimum value. We also need a variable to store the next item which was read from the file. So if we look in our sample code here, I do have a data file that is called 200randomnumbers.txt, and you can see it does indeed contain 200 random numbers. They are all integers which happen to be larger than 0. So in this case, I'm working with integers, but you never know, someone could have been mean and thrown a double in there. So I'm just going to go ahead and declare double variables to hold my numbers, just to be safe, in case there was ever a decimal in that data file. So let's declare those variables. So let's make an input file name to hold the input file. What else do we need? we need next value to store the next value that we read. We also need to declare the maximum value and the minimum value. These are, again, to hold current max and minimum values. And so we've declared our variables. So the next thing we need to do is declare our input file stream objects. Here we are only writing to a file, we are only reading from a file. We do not have to output to any files. So we only need an input file stream object because we are just reading from a file. So I'm just going to go ahead and name my input file stream object infile. Next, I need to open my data file. So I go infile.open, and remember, the data will be stored in the input file name. How do I know what my input file name is? Well, I gotta ask my user, right? So here we'll just say, please enter the name of the data file. And then we'll take in our input file name. And we'll open the data file using the open function. Remember, we also need to check for file opening errors. So we can say if our input file failed to open, what do? Then we can give ourselves a message. And then I'm going to go ahead and exit with code 0. So assuming we have a valid file name, we are now ready to start reading from our file. Let's use a loop to read all the items, or let's say to read each item from the file one at a time. So here I want to read as long as my input file stream object is able to read the next value. Then I start my loop. So what do I want to do here? Well, I just read the next value, so I need to check whether the next value is a minimum or a maximum value. And you'll see we don't necessarily know what range of values file might have. So if you are ever writing a program where you need to find the minimum and maximum, a good practice is to use the first item in your data file as the initial minimum and maximum. Then you can compare all the other values in the file to the first value. So before I start my loop, I'm going to read the first value from my file and set the minimum and maximum to that value initially. So here I'll say in file next item, next value, and then I'll say max value is next value. And also min value will be assigned next value. So notice I have read the first value into next value, and I set minimum and maximum to this very first value. Then here, when I start my loop, I'm actually reading the second value from the file, also reusing my variable next value. But I can check now whether that next value I read is larger or smaller than the current maximum. So I can say, all right, let's check. Is the newly read value larger than the current maximum? And is the newly read value smaller than the current minimum? So to check that, I can just simply say if next value, which we just read, if next value is greater than max value, well, then what do? Then I set max value to be, we update max value to be the new higher value, right? So if I read the next value in my file and I discover that that next value is higher than my initial maximum, I update my maximum value to store the new higher value. Similarly, I can check whether next value is less than my minimum value. And then if I am less, then I say min value is equal to next value. So notice I update min value to be the new minimum value, or the new lower value. So that's all we need to do in this loop for now. We're reading each item from the file one at a time. We are checking whether the item we just read is a new maximum and minimum value. If so, we update our variables. Finally, when our loop is finished, let's go ahead and first close our data file. And then we can output our maximum and minimum. So we output our maximum and we output our minimum. So just like that. Let's go ahead and try running this one. So here we go. Please enter the name of the data file to process. Well, I want to process 200 random numbers.txt. And hey, look at that. I found my maximum value is 100, my minimum value is 1. That looks about right. Let's try just for fun. What happens if we set the fourth value to something really big and maybe the eighth value to something really small, right? Let's make sure that we didn't just get lucky. Oh, well, see that? We correctly found our maximum and minimum. Another thing you could do is try modifying this program that we wrote in order to also find the sum and the average. If I wanted to do that, I declare a summing value and initialize to 0. And then I would also declare a counting value and initialize to 0 to count the values read. And notice here, I would just need to go back in. When I read the first value, I'd need to make sure I remembered to add the first value to the sum. And I'd also need to increment my counter. And then inside my loop, I could do the same thing. I could just add, I can add the next value to my cumulative sum. And I increment my counter. And this way, I can see what my sum will be. And then, of course, my average, we read how many values? We read count values. And then we can say the average is, I'm getting a warning. Oh, it looks like it doesn't like my indentation there. I did indent too deeply. So remember, I don't want these to be part of that if statement, but let's just go ahead and do Control-Alt-L to tidy up my code. Auto format. And let's go ahead and try running this. And look at that. Maximum, minimum we have. Sum is 37. Our sum looks a little bit off, doesn't it? Because we read 200 values. Let's make sure that we did this correctly. Do you see what happened there? I accidentally commented out my sum. That's not correct. That's why my sum was so low. So let's try that again. And there we go. Notice we actually ended with a pretty large sum. And that was due in part to this large number being present in there. And we got an average too. So if we reduce that number, we'll see our average will be, see now we get maximum, minimum, sum. And again, that's because we don't have that large number in there, the values are a bit more reasonable. So please try playing around with this program a bit. See if you could sum only the multiples of 3, or find the average of just the first 5 numbers. You could play with this a little bit. You'll find the more you play around with these different types of code, the easier it will be to manipulate files. Lastly, let's just briefly demonstrate what happens if we give it a bad file. Notice if we have a bad data file, our error message triggers. Well, I hope everybody found this demo helpful. And if you have any other questions about it, please feel free to reach out. All right, so this concludes our discussion of data files. And I hope you found the examples and demos in this video to be helpful as you start getting comfortable with loops and data files. Coding up the examples from scratch and playing around with them is a really good way to learn. So hopefully now you understand how to manipulate data files, how to use loops, if statements, and booleans to read and write the files. And now you should be able to write some simple programs that use data files. If you have any further questions on this, feel free to reach out. Thanks everyone, and we'll see you in the next video.